Um, I tweaked this one tiny bit. You remember there was a space before on Friday, April 25th? Yeah, I'm just trying to wait for these people over here. Hello, ladies. Okay. Anyway, I put in one empty slot there. I had a blank there before. And, I already told you we weren't going to have a test on 7, 9, 10. We're going to, actually, Chapter 11 is quite short and just got a few more probability rules. So that's going to be our last activity. And we may do a little of that today. It depends on how many questions you have for me on Chapter 10 assignment. But we probably will be doing that on Friday. So that's the one tweak on here. So what I've got in here is a scan of my Chapter 10 assignment. And I thought I'd see if you had any. I know you probably had a little trouble because this goes way back to Chapter 3. Then you've got that sigma over the square root of n thing. And then you've got some greater than versus less than. There's a number of little things that can trip you up. So I'll open it up to questions on Chapter 10 assignment. Yes, 21. Let's see, 21. Yeah, some of these, that scan isn't the greatest. You might not be able to read it. Okay, first, let's go to the problem and see if we can make sense of it. 21, the cost of internet access. The amount that households pay service providers for access to the internet varies quite a bit, but the mean monthly fee is $28, standard deviation 10. The distribution is not normal. Many households pay about 10 for limited dial-up or about 25 for unlimited, but some pay much more for faster connections. A sample survey asks an SRS of 500 households with internet access how much they pay. Okay, key word there, SRS, sample. So what do you have to use for standard deviation? You got to use the one they gave you, 10, but divided by the square root of 500. So I don't know if you can see this here, but you see how I calculated sigma? I said sigma equals 10 over the square root of 500. And that came out to 0.44721. Now, when I did my z-score, 29 minus 28, notice I had to divide by the new standard deviation. It gave me a z-score of 2.236, and then I was able to go to my table. The only problem is they wanted to know greater, didn't they? Yeah. Exceeds is the key word here. And the table gives you less than, so you notice I had to do a 1 minus. So my final answer was, what, 1.25%? Yes? 23. Mm-hmm. Yeah, just hang on. Make sure we get, that answers your question. 23. Making auto parts. Automatic grinding machine. Prepares axles, target diameter 40.125 millimeters. The machine has some variability, so the standard deviation is 0.002 millimeters. A sample of 4 axles is inspected each hour for the process control purposes. Records are kept. What will be the mean and standard deviation? Okay. So I see the word sample again. So when I calculate my new standard deviation, I have to take sigma and divide by the square root of n. And so, man, does that make a difference? It cuts your standard deviation, in this case, in half. Huge difference. So anyway, here's how I answered the question. See if you understand this. By the way, even though this one, which one was it? Sorry about my poor memory. Which problem was it that said it was not normal? Is that yours? 21? Or was that this one? Oh, you guys don't remember. Which one?
21 was the one that wasn't. Yeah.
Anyway, I should have made one more comment about that. Why do we still use this notation even though that was a non-normal distribution? Well, the answer is because when you do sample distribution, we didn't do very many. Oh, yeah, it was 500. Because we get a healthy number, it becomes normal anyway. That's the central limit there. So anyway, on this problem, when I get all done, I wrote my answer like this. The mean should be the same as the mean they gave us. The standard deviation, though, should be this new one that we calculated. So this is a way you can actually write your answer. Cheers.
11B.
11B. Let's see what's going on in 11. Okay, I'm going to look at A first. ACT scores, okay. Mean 21, standard deviation 4.7. Okay, part B. Take an SRS of 50 who took the test. What are the mean and standard deviation of the sample mean score X bar of these 50 students? So that's the first part. And the mean is 21. What's the standard deviation?
4.7 divided by the square root.
Yeah, and you should come up with about 0.66468. Okay, what was the second part of this question? What's the approximate probability that the mean score X of these students is 23 or higher? Okay, so we do our z-score thing, 23 minus 21 divided by our new standard deviation. And that gave me this number, 3.008. I go to my table, and I get 0.9987, I think is what that says. But because they wanted to know greater, I had to do this 1 minus thing. And then you wind up with this really tiny, what, 0.1%? 7? 7. Measurements in the lab. Juan makes a measurement in the chemistry lab, records the results in his lab report. The standard deviation of students' measurements is 10. Juan repeats the measurement 3 times and okay, so there's his sample, 3. Records the mean X bar of his measurements. A, what's the standard deviation of Juan's mean result? So wouldn't that be 10 over the square root of 3? Okay. And then what's the second part of it? B, how many times must Juan repeat the measurement to reduce the standard deviation? Oh, that's an interesting question. Okay, 7. Okay, I don't know if I haven't shown you why. I thought I would do a little better job of showing you why, so let's do it. How many times does Juan have to repeat the measurement to reduce the standard deviation down to 5? Okay, right now the standard deviation is 5.77. That's what I got. So how can we get that down to 5.0? Well, I just tried 4. What happens if you use 4? Well, now this changes to 10 divided by the square root of 4. 10 over 3 is 5. Ah. So I didn't show you how I figured it out, but there, I just explained it to you. So, you know what we could have done? We could have just called this the square root of n, and then just set it equal to 5, and we could have solved for it. But in this case, it was the very next one we tried. So, you've been waiting, haven't you? Yeah, I think you had your hand up.
Yeah, 37.
37. Is everybody clear with the one that's up here, so we can move on? Number 37. This time, what's happening? Oh yeah, I do have a note in my book on this one. can't tell if it's a population or a sample. Let's see if that's true. Is the quality okay? Statistical control means that a process is stable. It doesn't mean that this stable process produces high quality items. So you're supposed to go to this mesh tension process. Examples 10.8 and 10.10. The process was in control with mu being 275, standard deviation being 43. The current specs set by customer for mesh tension are 100 to 400. What percent of monitors meet these specifications? Yeah, the biggest problem here, and I wrote a note in the margin, and I should have passed this on to you. I can't tell if this is a population or a sample, or is there a clue back in 10.8 and 10.10? Anybody look in those examples? I think we better take a peek back there. Example 10.10 I see is on page 269. Now there it seems to indicate it's a sample. Where is it? Because there they use this signal.
I did it as a population.
You did it as a population?
Yeah.
You got it right?
Before you were back before.
I guess that's because they never did say what the sample size was, did they? So I guess we have no choice. That makes sense. I just thought it was a... I will say this. I'm not real nuts about this question on one of my tests or exam because it just was a little unclear that way. I would rather that be real explicit. Okay, so using it as a population, what percent of monitors go between 100 and 400? Well, all we got to do is find the z-scores for those things. We should be able to do it. Now, let's see if that's what did I do it or didn't I? 37. Okay, looks like I did. So I took the first score of 100. I found the z-score, just x minus mu over sigma. And I got negative 4.07. Well, if you go on your chart, that's a goose egg. I'll just show you. If you haven't looked already, you notice how the chart only goes down to negative 3. It doesn't go any lower than negative 3.4. And I don't know if you remember this, but I told you that if you ever get a number lower than that, just basically, you know, if you look at the reading, what's the lowest reading already in the table? 0.0003. So if you're below that, you can just count it as 0. So I did. The other one is what? 400. And that one came out to a z-score. Man, I can't read that very well. I think it's 2.7. And I looked up the percent, and it was 0.9985. And of course, when you subtract 0.9985 minus 0, you get 0.9985. So now, does that answer the question? Yeah. What percent of monitors meet these specs? According to what I've got, 99.85%. That's a really strong number. Part B, which I don't know, what's different about B? The customer has now set tighter specs, 150 to 350. What percent meet these? Well, you would just redo the problem. This time you do 150 and 350. And by the way, what's going to happen to the percent of monitors that meet those specs? More stringent specifications, not such a high percent are going to meet the specs. Yeah. We're going to have some more rejects. Hi. 27B. Auto accidents. Number of accidents per week at a hazardous intersection varies with a mean 2.2, standard deviation 1.4. This distribution takes only whole number values, so it's not normal. So in other words, you can't have 3.7 accidents. You can only have a whole number of accidents. That makes sense. Which causes a problem. See, these other things you can have like tenths and things like that, but here you can't. So you can't have this nice smooth graph. So anyway, that's a little bit of a problem. But what's going to make it right anyway? Probably they're going to do a sampling distribution, aren't they? Yeah. They take a sample of 52 because each week they take a sample. So now we have a sample, and the fact that we didn't have a normal distribution doesn't matter because of the central limit there, and it will be normal. Okay. So what's the approximate probability that x bar is less than 2? Okay, first of all, good news. It's a less than. We haven't had too many of those, so I don't have to subtract from 1. Okay, I'm going to guess, Kyle, the biggest, if I would guess, if people were doing this problem, the biggest trouble they'd have is they would forget to do this. You got to take sigma and divide by the square root of 52. You know, sigma over the square root of n. So, when you do your z-score for 2 minus 2.2, you have to divide by this new, not by 1.4, but by this newly calculated standard deviation, 0.1944. Z-score negative 1.03. Go read it off the table. No subtraction necessary on this one. Yep.
I got a question now on speed. Like, do you just
Okay.
do the same thing over? Like,
No. Let me see. First of all, did anybody have a question on B? Okay, let's go to C on that one. What's the approximate probability that there are fewer than 100 accidents at the intersection in a year? Okay, well, 100 accidents in a year is how many per week? 100 divided by 52? And that must be where I got this number from. Somebody want to check that? What's 100 divided by 52? It looks like that's what they said. Okay, so I didn't show very well on my paper here, but do you see what I did? I had to turn it into a weekly number, so I took 100 divided by 52. Now, find out the standard score. I got negative 1.43. I didn't answer the question yet. Well, no, I got to go to the table. What's negative 1.43? Negative 1.43 I show as 7.64%. Did they say less or greater? Yeah, fewer. So we're okay. 7.64%. So I didn't write the answer down, but we were right on the verge of it there. Good questions. Yes. 25. Glucose testing continued. Yeah, 24 was about this too. Okay, Sheila's measured glucose level 1 hour after ingesting the sugary drink varies according to the normal distribution. Okay, find the level L such that there's a probability only 0.05 that the mean glucose level of 4 test results, 4, there's your sample, falls above L. Okay, so we gotta go backwards here, don't we? They're giving you the probability. Can you go back and find the score? What number is this? 25. Terrible memory. So, I had to calculate this new standard deviation, 10 divided by the square root of 4, and that gave me 5. Does that make sense? And then I have this backwards thing here. I don't know x. I do know the mean, and I do know my new standard deviation. So now, using a little bit of algebra, where did I get this from? What was the problem saying? Oh, 5%? Yeah. So, I'll show you, let me just show you where I got this number from. It says you want it to be less than 5%. Go to your table, and this time you're reading out of the inside of the table, and you're trying to find as close as you can to 0.05. And it's pretty close to negative 1.6. What? Right between 6.4 and 6.5. You see that? And so what I did is split the difference. What's half between 0.6 and 0.5? 0.64 and 0.65? 0.645. So that's where I got this from. Now just do a little algebra. Multiply both sides by 5. Add 125 to both sides. So the key glucose level for her is 133. Just a tad over 133. I gotta show you, this software just got updated. That's really cool. With the magic pen, I can do things like this. Highlight in an area. Or I can go like this. Anyway. Free upgrade. Yes?
We go through the second part of 15.
The second part of 15. Well, okay, let's see what's going on there. First of all, what's going on in 15? To get this set up, 15 says auto thermostats. And of course, that goes back to 1013. Let's see. Temperature that turns on the thermostats has remained in control with a mean of 75 degrees Fahrenheit, standard deviation a half a degree. What are the natural okay. So now you're on to what? Part B?
Just the second question.
Which simply says what range covers the middle 95%. Okay, gotcha. All right. Well, 68, 95, 99.7. 95 is the when you go 2 notches either way. So all you really had to do is take the mean and go 2 notches up and 2 notches. Instead of what? Instead of 3, as you did in natural tolerances? That's it. And now, do I show that on here? Yeah. So do you see what I did? 75 plus 2 sigma, 75 minus. So I wound up with these two numbers, 76 and 74. Yeah. And this, there was nothing about control limits in that problem, was there? It was all natural tolerances. As soon as I go to control limits, then what do I have to do? Instead of sigma, I would have had to use sigma over the square root of n. But this was natural tolerances, so I could just use sigma. Yeah, awesome. Okay. Yep.
You explain number 29.
I'll try. 29. Returns on stocks. The distribution of annual returns of common stocks is roughly symmetric, but extreme observations are more frequent than in a normal distribution. Because the distribution is not strongly non-normal, the mean return over even a moderate number of years is close to normal. Okay. In the long run, annual returns, not adjusted for inflation, have a mean of 13% standard deviation. Holy cow, it's a big standard deviation, isn't it? Anyway, Andrew plans to retire in 40 years and is considering investing in stocks. What is the probability assuming the past pattern continues, that the mean annual return on common stocks over the next 45 years will exceed 15%. Okay, 40 years. Now, that's a little bit sneaky, but and since they're talking about annual, it's actually a sample of size 40. So actually, they didn't come out and tell you, but do you see how n is 40 in that one? Okay. Now, let me get it up. 29?
Won't it be 45?
Yeah, I know.
Why is that?
Because it says, what is the probability that the mean annual return on common stocks over the next...
Oh, yeah. I should be using... I was looking at that previous sentence about him retiring, but yeah, I should use n equals 45. Sorry. A little lower, they updated that. What is it, 29? Oh, there we go. Okay, so this is awfully sloppy, but what this is supposed to say here is 0.17 over the square root of 45. And that's your new standard deviation, and I came up with 0.0253. Now we can go ahead and do this problem. Oh, one more thing. How do you get, what is it? First question was, will exceed 15%. Will exceed 15%, which means it'll be less than 85%. So now you go to your table and you try to find 85% in the inside of the table. I want to show you where I got this from. That does not sound right.
That's B.
Oh, I got these switched around. Yeah. I don't know why I have A after B. Yeah, that sounds a lot more like it. So now, anyway, 85%, if you look it up in the table, according to this, I got I got 0.7905. Does that look right? 0.79 would bring me to 70.
78.52.
Something goofed up here. What am I doing? Exceed 15%. That means 85% would be below it, right? 85% below. Why am I not getting that answer? According to this, 85% has a z-score of 1.035. I don't know why I have 0.7905.
Because would you just find 0.79, whatever?
And subtract from 1?
Would you just find that inside the table? 0.79?
But 0.79 is not in the problem.
If you find 0.79, then it would be 78.52 inside the table. And then you subtract that from 1.
So you're saying the z-score is 0.79?
Right, and then inside.
Where did you get that from?
I don't know, I just did the math, and it came out to be the same answer that they had.
Oh, okay, I got it. I guess I was thinking it's a backwards problem, and it's not. Yeah, it's 0.15 minus 0.13 divided by our new standard deviation. You're right, it's 0.7905. Now you look it up in the table. And you have to subtract from 1 because it's exceeding. Answer 21.48%. Yeah. So that was part A. What's the probability that the mean return will be less than 10%? Okay, I don't know why I did B first, but now you get a negative 1.19 and no subtraction from 1 necessary. Just read it right out of the table. I'll tell you what threw me off. I don't know, maybe this throws you off sometimes, but when they give a percent in a problem, doesn't it seem to imply that you have to read the table backwards? Because these guys in here are all percents, right? The problem was, everything in this problem was percents. Even the mean was 0.13. And so sometimes I get thrown off and think, oh, I got to read the table backwards. That wasn't the probability. That was simply what? What was the percent in this problem? Stock gains. It had nothing to do with probability. And so a lot of times when I'll see a decimal, I don't know, does that make any sense? Percents or decimals, right away I'll think, oh, I got to do the table backwards. And I got to remember, in this case, the natural statistics were decimals. So I made it a lot harder than it had to be, and I made it wrong. So this is correct. Good questions. Glad we had a good, healthy time for this, and I hope this helped. Others, you want to go through? So it's a good thing we had a good amount of time for that, wasn't it? All right. Well, we're going to just start.